Okay, in this problem, there's no air resistance, there's no friction like loss of energy. We live in a perfect world. Also, the spring and the popper split in the demonstration. Pretend they didn't, because that might muddy some values. Pretend we have the mass and that we measured everything correctly. Um, I think that's it. Hello. Today's energy problem, we're going to be doing a spring and finding its spring constant. Uh, for the problem I have behind me, but for a demonstration, we have this little ruler attached to this Lego so it stays straight. This broken spring popper toy, a little pen spring to go inside, and then we'll compress it, see how high it jumps. And then for the little model I drew, we know the mass of the spring, and we're going to measure the compression of the spring, which is xs, and the max height of the spring that it goes up, h, to find the spring constant k. So essentially we know m, the change in the length of the spring, and the height. It jumps up. Right here it's at rest, compressed, and then jumps up. So, I don't know if you can see it, but the spring is about this tall, right here. And then, since the phone is here, it's putting it at a height, initial height of whatever this is. Pretend I measured it. Pretend I also know the mass of the spring and the popper. Hopefully, the camera's not placed accordingly. Pretend the camera is at a good level and not angled in a way that makes it misleading how high it goes.
Come on then. Yeah, twit.
Oh my god. It is barely touching the surface. How are you not? Was it? I don't even know. So, this little equation I have here is something I write all the time when I'm doing energy, at least with like classical physics. UG is the potential energy due to gravity, KE is the kinetic energy, and US is the potential energy due to a spring, and the little zeros I have are the initial, and the little F's subscripts are the final, meaning that all the energy at the start should equal all the energy at the end. This is due to energy conservation, and assuming you did your trials and you found your average H and you found your compression of the spring X, we also know at this point the initial velocity is 0 because it's not moving when you compress it and it's just there. And the final velocity when it reaches that point where it starts to fall down is also 0 because it's moving up, stops moving, starts to come down. So this is 0. From that, we know this is the initial state, this is the final state, by the way. We know kinetic energy at the start is 0, and at the final as well. There's no gravitational potential energy, assuming this is the 0 mark. So, and there's no spring energy at the final mark, making this a simple like that. And then you plug in your equations for that, which is 1/2 kx squared and then you solve for k, which will be 2mgh over x squared. And that's how you would solve for k, and then you plug in all your values to get that. Oh my. Okay. Okay. And then I'm gonna barely touch the surface. No, come on.
No. No. I did look. Did it
Did it work?